Hello, students in the ASU online class SES107, A Solar System Journey. Welcome. I'm Professor Jim Bell. I'm a faculty member in ASU's School of Earth and Space Exploration. I'm also a planetary scientist. I study planets, moons, asteroids, comets, and all kinds of stuff all over the solar system. I'm actually trained as a geologist, but I have to use the tools of an astronomer like telescopes and like spectrometers to do the kinds of science that I'm interested in. I'm also very heavily involved in a variety of NASA robotic space missions. Maybe you've heard of the Mars rovers, Spirit, Opportunity, Curiosity, and Perseverance, for example. I've been involved with those, working with a bunch of colleagues here at ASU and elsewhere to build and operate cameras on these amazing NASA rovers. I use these kinds of images to study the history and geology of Mars and what it can teach us about our own planet Earth. You can learn more about my research background and the work my students and colleagues do in my research group at ASU by doing a Google search for Jim Bell ASU or visiting http://jimbell.cc.asu.edu. So check it out. I am super excited about helping to guide you all through this online course, which I think is very nicely designed to be a good, basic, fundamental introduction to the modern study of our solar system. So I think it's going to be a lot of fun. Now, what I wanted to do in this short introductory video is to kind of walk you through major parts of the syllabus. I want to make sure everybody's expectations are aligned here at the beginning of the course and remind you that the syllabus is posted on the Canvas page for the course. I'll be sending out announcements over the course of the semester via that Canvas page, and I'll be updating the syllabus if it needs to be updated over the course of the semester as well. So, what it describes in the syllabus, and I'll just read it, it says, this online course is an introduction to modern planetary science, the exploration of our solar system by astronomers, geologists, chemists, physicists, engineers, astronauts, and even biologists. We will study the historical and modern science of the sun, planets, moons, rings, asteroids, and comets in our solar system, and about new planets being found in other solar systems. Along the way, we'll learn about the scientific method as well as the specific techniques used in modern planetary science and space exploration that enable us to apply what we learn about our solar system neighbors to the study of our home planet and vice versa. So this class has a number of expected learning outcomes, 6 major learning outcomes, and I'll just read them off to you. By the end of this course, students should be able to, 1, identify the inventory of our solar system, including the relative sizes, locations, and motions of the sun, planets, major moons, major asteroid regions, and major cometary classes. 2, obtain, analyze, and interpret quantitative data about objects in our solar system and describe their locations and movements using scientific terminology. 3, explain the theory of the formation of our solar system 4.6 billion years ago and assess the validity of that theory, including the strengths and weaknesses of the supporting evidence. 4, recognize and describe the fundamental processes that cause changes on the interiors, surfaces, and atmospheres of solar system objects, including the creation and modification of graphical and mathematical models of planetary motion, eclipses, phases of the moon, and plate tectonics. 5, apply their understanding of solar system exploration to explain specific planetary scale issues like climate, impact threats, habitability that we encounter here on Earth. And finally, number 6, demonstrate how science works via observation, constructing hypotheses, and testing through reasoning and critical thinking using examples from planetary motions and eclipses. Critical thinking. I love critical thinking. That's really important nowadays. So perhaps the most important part of this course is the textbook. Here it is, the textbook. This is the Cosmic Perspective, the Solar System edition, the 10th edition of this book from Pearson. It obviously comes in handy, hard copy like this for those old school folks like me who like old-fashioned books, but it also comes as an ebook, and it's a really good ebook to be able to use because you can search through it very easily. It'll work on most kinds of computers or devices like tablets, laptops, desktops, maybe even mainframe computers, I don't know. You can get the ebook from Pearson, the publisher, via the course Canvas site with details provided in the syllabus. I really love this book. I've been teaching this class for many years in person out of this book and for a few years online as well with earlier editions. I know the authors. I believe in the way that they believe that students can best learn. I believe in the accuracy and the accountability that they bring to this subject. They're all professional astronomers or planetary scientists. I've helped over the years by providing them some pictures and some reviews of various content in the past, and so I can really recommend this book highly. I think you'll enjoy it. Also, the book comes with an online tool called Mastering Astronomy, where you'll do the homework, the problem sets. I really love the problem sets. They're all going to be multiple choice. I'll go over this all in a moment, but they offer a lot of interactive material because it's online. Diagrams, figures, widgets you can move around and mess around with visually. I am personally a visual learner myself, and so you'll see that most of the homework questions involve some pretty cool visuals of one kind or another. So this is really the most important part of the class, the textbook and access to the online tool where the problem sets are done for the homework. My job is to try to augment the content in here in this textbook through online lectures, which I really believe can be as much or as little augmentation as you think you need. I've chosen the homework questions for you to work on, the problem sets, the kinds of problems you'll be trying to address after you do the reading, and I've also put some videos together along with each chapter. Within each of the learning materials, part of each Canvas module for the course, you'll find one short sort of YouTube-style summary video, usually 5-10 minutes or less, covering the main topics of each chapter, plus a much longer, usually like 45 minutes to an hour, full lecture that I've recorded for each chapter. The full lecture covers the same material as the book, but also includes some extra materials in each topic that I've pulled together from a variety of other resources and personal research experiences over the years. Some of the longer videos also include very recently updated content at the end because some aspects of solar system science and exploration are changing very rapidly, even semester by semester. So I've tried to provide some updates at the end where appropriate. Now, viewing those full lectures is optional, but if you're interested in lots more material, details, stories related to each chapter's topic, I encourage you to check them out. Please also remember that both the TA and myself will be available for help online or by email if needed, and more details about that are coming in a few minutes. Okay, so the homework is done through Canvas in an online tool called Mastering Astronomy from the Pearson Publishing Company. It's only accessible from the Course Canvas website, so the Canvas site for the course is your one-stop shop. All of the assignments in Mastering Astronomy will be available to you that way. They'll be based on general concepts with lots of visuals, pictures, graphs, animations. No math problems, no essay problems. Those can be challenging, I know, but also, it can be daunting to grade with large numbers of people in this class. I think everything in multiple choice will be just fine. One nice thing about Mastering Astronomy is that you can try multiple times to answer each question. You lose a little bit of credit each time, maybe a third of a point, but you can get partial credit by eventually getting yourself to the right answer. And the assignments can give you hints along the way. There are 15 chapters of reading and homework assigned during the semester, and you get to drop your lowest homework score. But to do the online homework, you must register with the Pearson Mastering Astronomy site as soon as possible to do that online homework. I describe how to do that in Canvas, on the home page for the course, and in the syllabus, so please follow the instructions to access the homework and register as soon as possible. If you're having problems with that, there's information in Canvas and in the syllabus about how to contact and get technical support help directly from Pearson. I personally don't know how to fix things usually, so you're going to have to follow that technical support link to get help that way. But we provide lots of information on how you can get that help. Second important thing, in addition to the homework, there are also laboratory activities, labs. The class has both homeworks and labs due most every week. There are 6 required online lab activities and 1 bonus lab activity in an online platform that's called Argos. Argos is a really cool platform. Students have really liked these lab activities previously. But again, you have to register in the Argos site as soon as possible to do the online labs. You can only access the labs through Canvas, and when you try for the first time, lab number 1, that's when you'll have to register in Argos. And just like for the homework site, there's technical support available for the labs if you need it, and I'll get into that more in a bit. Okay, I want to go over something next called the course planning map, which is appended at the end of the syllabus. If you go to the end of the syllabus, you'll find it there. It's a table. We can look at that, and you can see that it lists each week with each module and topic for that week, the objectives, the assignments, the materials covered, as well as the due dates. They're listed there week by week. So week by week, what are the assignments? What are the chapters you need to read? What are the homework sets you need to complete? What are the labs you need to do? And what are the deadlines? Deadlines. Remember deadlines. Some weeks are full weeks and some weeks are half weeks. Please pay attention to what is due when. You know the deadlines for the entire semester right now ahead of time. Okay, here's something else important to know for this course. Late assignments are not accepted without an official university accommodation. If there's an emergency or some other extenuating circumstance that causes you to miss an assignment due date, please reach out to the official ASU offices and programs that are listed in the syllabus so they can contact me about an extension. Extensions or incompletes cannot be granted without that official university accommodation. So please consult the syllabus about what to do if you have to miss an assignment. Similarly, please consult the syllabus if you need an extension based on the observance of a religious holiday or based on your participation in specific university-sanctioned events or activities. The syllabus has that information for you. If you follow all the rules on this, the TA and I will be able to work with you to help you stay on track or get caught up. The biggest problems that occur each semester are because students haven't read, understood, or followed the rules. So please take the time to read through the syllabus carefully so you understand the expectations for this course. Okay, in the first week in Module 1, you're going to get yourself registered in Mastering Astronomy in order to start the chapter homeworks. And I recommend that you also open Lab number 1 so you can get registered in the Argos website, even though Lab 1 isn't due until a week later. And then after that, every week, there's usually 2 chapters assigned for homework and 1 lab assigned. So please note the due dates and the deadlines module by module. Now, importantly, all of the homework and lab assignments are open on the very first day of class. You can start them anytime you like, but they have different due dates as we go along. Homeworks and labs are generally due on Sunday nights by 11:59 p.m. Arizona time, pretty much every week. All of your assignments and due dates are known now. So please plan to meet those deadlines. It's a compressed schedule. This short semester format crams all this content into just 7.5 weeks. So please work to keep up. We will go through the entire solar system. You'll learn about the sun, the small bodies, the asteroids and comets. You'll learn about the planets, large and small. We'll talk about the terrestrial planets, the gas giant planets, the ice giant planets. What does that mean, ice giant? You may have never heard about that term, but you'll learn about it. We'll also talk about planets around other stars. There's a whole chapter dedicated to that, which is a brand new and exciting field of astronomy. And finally, we'll talk a little bit about astrobiology, the study of life in the universe, life on Earth, and the potential for life elsewhere in the galaxy and beyond. It's pretty cool stuff. I think it's great fun. I think it's going to be an incredibly interesting set of topics. We'll cover most of the solar system part of the textbook. And as you can tell, there's a lot of work to be done. We are cramming a bunch of work, an entire semester's worth of work, normally 15 weeks, into this 7.5-week short semester format. So you're going to have to put some time into it. And what kind of time commitment is expected? So look, I know everybody works at a different pace. I'm sort of typically expecting each student to probably spend 1 or 2 hours just reading each assigned chapter, maybe taking notes or highlighting. Then I'm expecting it'll take roughly 30 minutes to an hour to work on each homework assignment, and maybe half an hour to an hour to work on each assigned lab as well. It's a lot of material to cover and not a lot of time. Like I said before, we're cramming it all in, so please don't fall behind. Please keep up with it. It's a 4-credit course, and it satisfies the SG General Science requirement for ASU undergraduates, so I'm expecting you to put the hours in. Okay, let's talk briefly about grading. This is all in the syllabus, but I just want to briefly go over it here. Your grade will be based on 2 components. First, homework, and second, labs. Homework is 70% of your grade. Labs will be 30% of your grade. Over the course of the semester, you're going to get 15 homework assignments based on each of the chapters you're reading. They're all multiple choice assignments, and they're associated with each specific assigned chapter. And there are links between the online homework questions and the ebook versions of the textbook. That's partly why I recommend that you go with the ebook. Every homework assignment, each one is worth 5 points, 5 percentage points, 5% of your grade. You're allowed to drop 1 out of the 15, your lowest one. Maybe you're sick part of 1 week. Maybe you can't catch up on it by Sunday night or whatever. You can drop your lowest score. That leaves 14 that you'll be graded on times 5% each. That's 70% of your grade. The lab activities, there are 6 of them that are required. The 6 are all open for working on at the start of the course. They're due starting in the 2nd week of the course. There's 6 of those. They're also worth 5% of your grade each. So 6 times 5%, that's 30% of your total course grade. 70% homework, 30% labs. Now, for each lab, you're only graded on completion of the questions and activities in the lab. There are no points for correct answers or loss of points for incorrect answers. In each section, you'll be asked to do some activities and to answer certain questions. If you get a question wrong, it'll give you some hints and you can try again. So I think it's good that way. There's lots of great graphical demos and some virtual field trip activities built into these labs. If you stop halfway or run out of time halfway because you waited till half an hour before the deadline to start the lab, you'll get 50%. If you don't do a lab at all, that's a 0. There's also a bonus lab number 7 at the end of the semester. If you do the bonus lab, you can use that score to replace your lowest score in the other 6 labs. And if you ace all 6 earlier labs, you can use your bonus score to get a little extra credit at the end. And so see the syllabus grading policies section for details about homework and lab grades. Letter grades will be given on a standard scale, and I've listed that standard letter grade scale boundaries in the syllabus. There could very well be some curving of the grades depending upon the performance of the class, but the letter grade boundaries in the syllabus won't be raised compared to what's shown there. So check it out and let me or the TA know if you have any questions on the grading or the assignments. Okay, almost done here. I will make a confession to you now. Teaching an online class is a relatively new thing for me. I used to teach this class in person. I love teaching in person for a variety of reasons, but I know that online classes are very popular these days and also super convenient for many students who have day jobs or families or other specific circumstances that make enrolling in in-person classes on Tempe campus, for example, difficult, inconvenient, or impossible. So you're all part of an interesting online experiment for me in my teaching career. I've offered this class online a few times already, but I still have a lot to learn on the technical side and on the education side. So I'm going to rely on all of you to provide me and the TA with constructive feedback on what's going well and maybe what's not going so well. And there are several ways to get us that feedback: by email at the addresses listed in the syllabus and on the course Canvas page. You can use the Ed Discussion tool in Canvas, or you can talk with us directly during our live office hours on Zoom twice a week. So see the details on days and times in the syllabus and on the course Canvas page for those office hours. During those office hours, we can help with homework, lab questions questions about the reading, or maybe just, hey, what's going on Mars this week, Professor Bell? That kind of thing. If you can't attend any of the office hours that we've scheduled, please email us and one of us can arrange to meet at another time that we can agree on with you online or perhaps even on campus. Now, a common reason that students reach out in this class is because they're having some technical problems with the homework site or the labs. If you follow the instructions in the syllabus and in the announcements in terms of which browsers to use, how to navigate the labs, what to do if certain common problems occur, then hopefully you won't have technical problems. But if you do, odds are that neither me or the TA can actually fix it. So please carefully read the homework, lab, and technology support section of the syllabus to find out how to contact the right support people at Pearson or at Argos to get you the help you need. So please also know, however, that technical support is likely not going to be available on the weekends and definitely not in the late hours on a Sunday night just before the assignments are due. So please start the assignments during normal Monday through Friday work week hours, typically 9 to 5 in Arizona, so that if you need technical help, you can get it before the due date. I'll also be sending Canvas announcements to all of you each week outlining the next assignments and maybe some other fun astronomy or planetary science topics that come up from week to week. All right, I think this has been kind of a basic high-level introduction and walkthrough of the syllabus. There's lots of other important information there, like a reminder about ASU's academic integrity policy. So simply put, please don't cheat, because you're likely to get caught and you're likely to get in a lot of trouble. If you get to the point where you think you need to cheat in order to do the work or to catch up, please reach out instead to me or the TA or to ASU's Student Advocacy and Assistance Office, and let us all try to help you get through any tough times, please. There's also a reminder there that late assignments are not accepted in this course without official ASU University accommodation documentation, and details how to obtain such accommodations for a variety of potential situations are provided in the late or missed assignments section of the syllabus. So please read and understand that section carefully. All right. I'm sure you have questions. You can find many of the answers on the course Canvas page and in the syllabus. So again, please read those resources carefully. Finally, I want to thank you for enrolling in this course. I want to thank you in advance for your patience as the TA and I figure out how to best offer you this online course. I'm a professor and a researcher in planetary science, but I also consider myself a lifelong learner, maybe like you. So I really, really hope that you are all as excited to learn about the solar system as I am. Thanks, and I'll see you again real soon.